Welcome to your favorite channel, the Mathematics Appreciation. Today we'll be talking on simultaneous equation in three variables. Where we have three sets of equations and we'll be expected to get values for the unknowns. Now let's go to the board. We have an example here on the board. It says solve for the unknowns in the set of equations below. We have the first equation to be x plus 2y minus z equals 4. The second equation is 2x minus y minus 3z equals 3. And the third equation is 4x minus 2y plus z equals minus 2. To be able to achieve our own end here, we start by numbering the equations. And the numbering of the equation has no rule of thumb. We can label it with anything and choose to label this equation 1, equation 2, equation 3. The labeling is for reference purpose. Okay, so the first thing to do is to pick any pair of these equations and try to eliminate one of the variables. The resulting equation will be in two variables. We'll keep that equation aside. Then we come back again and pick another pair different from the first one we picked earlier. And we eliminate the same variable we eliminated before in the first pair. And we have two sets of equations in two variables. And we then use the method of either substitution or elimination to tackle to obtain the values of the variables. And after that, we do back substitution. Okay, let's start. If we choose to pick equation 1, and 2 first, and we choose to eliminate variable x. Okay? Like I said earlier, the variable you wish to eliminate is the discretion of the person solving the equation. You can choose to eliminate any of them first. And one thing you have to bear in mind is that the one you choose to eliminate in the first stage must be the same you're eliminating in the second stage. Now that we're eliminating x, we want to eliminate x. In the second stage, now when we are picking another pair of equations, we'll still eliminate x. So, to eliminate x, we'll now multiply equation 1 times 2, and we multiply equation 2 times 1. We do that so that the coefficient of x in equation 1 and the coefficient of x in equation 2 will be the same. And that will enhance the elimination. So this particular point turns to 2x plus 4y minus 2z equals to 8. You can call this equation, equation 4. And we now have here 2x minus y minus 3z equals 3. We call that equation 5. So we've been able to multiply equation 1 with 2, the coefficient of x in equation 2. And we multiply equation 2 with 1, which is the coefficient of x in equation 1. So at this point we'll say, so we can eliminate that value, that variable x, we say equation 4 minus equation 5. Here we turn to 2x minus 2x plus 4y minus y minus 2z minus 3z. And that will reduce to 5y plus z equals to 8 minus 3. And this will further reduce to 5y plus z equals to 5. We call this equation 6. That equation has now reduced to the equation with just two variables in y and z. We'll keep it aside. I will now go back to original set, which has a three set of equation, and pick another b different from the first b. You can choose to pick 1 and 3 or 2 and 3 this time around. So if we pick 1 and 3, picking 1 and 3, now, and to eliminate the stem x, we now have to multiply equation 1 by 4. We multiply equation 3 by 1. Okay, so this will result in 4x plus 8y minus 4z equals 16. Order equation 7. And we have 4x minus 2y plus z equals minus 4 is equation 8. Okay, to eliminate x now, simply say equation 7 minus equation 8. And that will give us 4x minus 4x plus 8y minus 2y minus 4z minus z equals 16 minus 2 equals 16. Let's write that so I can have enough space. Equals 16 minus 2. Okay? So this will turn to 0. 8y minus 2y is 10y. Minus 4z minus z is minus 5z, which is equal to 16 minus 2 is 18. So we call this equation 9. We now solve equation 6 and equation 9 simultaneously to obtain the values of y and z. So we now solving equation 6 and 9 simultaneously. Using, I'll choose substitution method. Except from equation 6, we can say that z equals 5 minus 5y. Call that equation 10. Then we say substitute equation 10 in equation 9. So that we have 10y minus 5 into 5 minus 5y equals 18. At this point, we simplify to obtain the value of y. So this is now 10y minus 25 plus 25y equals 18. So collecting right hand, we have 85y equals to 18 plus 25, which is equals to 43. Therefore, y equals 43 over 35. That's the value of y. At this point now, we do what we call back substitution to be able to get the value of z here and the value of x here. So At this point, we can clean out of this so that we can achieve our end. Now we've obtained the value of y to be from 3 over 35. We move ahead to obtain the value of x. Then put in y equals 43 over 35. In either equation 6 or 10, I choose to put in 6. We have 5y. Sorry, 5 into 43 over 35 plus z equals 5. So making z the sum of the formula, z equals 5 minus 5 times 43 over 35. It's the same thing as 5 minus 5 times 3 is 15. 5 times 4 is 20 plus 1 is 21. Okay? So if you take the LCM of that, we now have that z is equals to 35 times 5 is about 165. We show 55 times 5 is 25, carry 2. This time this is 15 plus 2. That's 175. Okay. It's 5. So 175 minus 215 over 35. And that is minus 215 minus 175. This is 0. This is 4. Minus 40 over 35. So z in this case is minus 40 over 35. Alright. We now move ahead to obtain the value of x by substituting y equals 43 over 35 and z equals minus 40 over 35 into either equation 1, or equation 2, or equation 3. I choose to substitute that value in equation 1. I'll play this part and have enough space to obtain the value of x. Okay, so put y equals 43 over 35, z equals minus 40 over 35, in equation 1, we now have x plus 2 into 43 over 35 minus 40 over 35 equals 4. Okay? So we have that x equals 4 minus 43 times 2 is 86 over 35 minus 40 over 35. We take the LCM, which is 35 here. And here we have 4 times 35. This is 20. This is 12 plus 2. So that's 140. 140 minus 86 minus 40 over 35. That gives us our x, which is the last variable that we have to obtain here. 140 minus 40 is 100. 100 minus 86 is 14. So we have x to be 14 over 35. Okay. So X is 14 over 35, Y is 14 over 35, and Z is minus 14 over 35. So in order for us to be sure that our result is correct, we now check. We do a check to see if we put the values in the original equations, if they will result in the value to the right of the quantity sign. So if we put that the values in equation 1, check. So we want to check if it's actually the right thing we've done. Putting these values in equation 1, we have 14 over 35 plus 2 into 43 over 35 minus 40 over 35. This is now 14 over 35 plus 86 over 35 plus 40 over 35. So the LCM here is 85. (14) plus 86 is 100 plus 40 is 140. And 140 divided by 35 is 4. So actually we are right because 4 is here. So with this we'll be able to obtain the values of x to be 14 over 35, y to be 43 over 35, and z to be minus 40 over 35. And we'll be able to check that our result is consistent with the set of equations, because the resulting value here, after we substitute the values in equation 1, is actually 4, as given in equation 1. Thank you so much for watching till this time. Please, I implore and beg you to share, like, and comment on our video, subscribe to the channel, and we'll appreciate it greatly. If there's anything you want us to do further, you can suggest topic and we'll treat it. Thank you very much.